In this video, we are going to talk about one-to-one functions. So we already talked about this section, but it's been a while. We talked about it when we went over section 3.1, when we first started talking about functions, and then basically we didn't really need to use it until we get to this section. And this section is 3.7 on inverse functions. So a one-to-one function is just a function where there is no repeated second coordinate. Okay. So if you have your function in ordered pair notation, and it's written as simply as you can write it, in other words, where you don't have any repeated ordered pairs in there, right? Then it's pretty easy to determine if a function is one-to-one or not, right? All you would need to do is to go through and look at the second coordinates and see if there's any repeats. So I have an 11, 7, 4, a 6, and a 1, right? So there's no repeats, so function 1 is one-to-one. All right, for function number 2, I want to see if this is one-to-one. So I would check, and here I can see I have a repeat, right, on the second ordered pair. Okay, and so this function is not one-to-one. Again, these need to be written reduced, so that you're not repeating ordered pairs in order for it to be that simple. But this is really just to get the idea of what one-to-one is anyway. You can see here this function is not one-to-one, right, because I have lots of repeats. The 7 is repeated 3 times, the 2 is repeated 2 times, right? So function 3 is not one-to-one. Another way of representing a function, as opposed from the ordered pair notation, is to use one of these diagrams, like this arrow diagram, right? And with the arrow diagram, it's really easy to see whether a function is one-to-one or not, because we're looking for repeated second numbers, right? And if you had a repeated second number, then one of these dots over here in the range would have 2 arrows coming into it. So you can see this one only has 1, this one has 1, this one has 1, this one has 1. So that makes this function a one-to-one function. This function is also, right, a one-to-one function as well. You can see that every arrow, right, coming into it is, there's only 1 arrow coming into it. And this function is not one-to-one, right? We can see because of 9 right here, we can see that the value 2 in the domain corresponds to a 9, and the value 3 also corresponds to a 9. So since I have 2 arrows coming in here, right, I have basically two ordered pairs with the same second number, and that's a 9. Okay, so this function is not one-to-one. The other way that we are going to look at one-to-one functions is with the horizontal line test. And with the horizontal line test, this one applies the most to the type of functions that we will be looking at, the most important ones. These ways of representing functions with tables or ordered pairs or with diagrams is useful for understanding the concept of what a function is and what a one-to-one function is. But really, what we want to do is look at functions written in function notation, with algebraic formulas and that kind of thing. It is a little bit difficult to tell, working through just algebra alone, whether or not a function is one-to-one or not. It's not too bad, but we're just not going to go into that. But we will talk about this horizontal line test. And the horizontal line test is a way for telling whether or not a function is one-to-one by looking at the graph. And so when I say function, I mean that it can be written as y equals a function of x. So y is a function of x here. All right, and the horizontal line test says the graph of a function is one-to-one if and only if no horizontal line intersects the graph in more than one point. Okay. All right, so you would think about having horizontal lines, right, through here. And you can see, because this graph is a straight line, right, no horizontal line is going to cut through this graph more than once. You might have some horizontal lines up here that don't cut through the graph at all, right, because it ends here, as signified by these dots, right? But no horizontal line cuts through here more than one time. So this graph is the graph of a one-to-one function. All right, this graph is definitely not the graph of a one-to-one function, and we can see that because of the fact that if I drew a horizontal line right through here, it's supposed to be horizontal, right? It would intersect the graph in more than one spot right here. It would intersect here, it would intersect here, right? So that is enough right there to say, hey, this is not a one-to-one function, okay? There are two different values that could plug in. And in fact, right, if I was a little bit more careful about it, if I drew the horizontal line, or tried to draw it right here at 1, actually, let's do it at, there's no good place there, but I guess the best place would be right here. If I drew this horizontal line right here, you can see it cuts the graph right here and cuts the graph right here. Okay, so if this graph were f, right, what that would mean is that f of 1 is 0, right? If I had the formula for this and I plugged in 1, I would get 0. Why do I know that? Well, because I know this point, right, is on the graph, right? So it has an x coordinate of 1 and a y coordinate of 0, right? So if I plugged a 1 in, I would get 0. And over here, right, that point where that horizontal line would hit the graph is right here. That has numbers, right, an x coordinate of 4 and a y coordinate of 0, right? It's supposed to be a comma. Okay, and so you can see I would have two ordered pairs, right, with a repeated number, or a repeated y coordinate, or second number, however you want to think of it. Okay, so this function is not one-to-one. All right, next one. This is the next example, and so if I take a look and I want to know, hey, is this one-to-one or not? Again, you can see the answer is definitely no, right? Because if I draw a horizontal line right here, I can see it intersects the graph in more than one spot, and that is it, right? I don't need to go any further with that, okay? So this graph is not one-to-one. All right, so that is a review of what we talked about in class about one-to-one functions. And this is the point in the class where this idea starts to become really important, right? Because the next topic that we'll talk about, the topic in section 3.7, is inverse functions, right? And in order for a function to have an inverse function, it has to be one-to-one, okay? All right, so that's it for this video. In the next video, we will talk more about inverse functions.